Great. Hi, Nodar's here. Oh man. Oh boy. All right. Well, Nodar's going to do the pull request review club next week. All right. I promised everybody there'd be little bounties for attending. I'm going to hold myself to that. You guys who are here, I'm taking a screenshot of the people who are in the channel. Go ahead and put an HNS address either in the HSD channel or send it to me privately as a DM. If you stick around for like half an hour, I'll send you like 10 HNS. Ideally, the goal of this is to get more people involved in the code, to see how it works, to see what contributing to HSD means at a technical level, and also hopefully to get more people involved, to show how easy it is, how little you have to do to like review a pull request or at least just participate. And if you are able to actually review the pull request and leave a comment, even if it's just something very simple, which we'll explain, I'll provide bounties for that too. I've got plenty of HNS that's being donated to me from people like Goldshell, and I'm happy to spread that out to users who want to contribute but maybe don't know how, or you don't understand JavaScript, or you've never really written code, or any of that kind of stuff. If you're here, you're curious enough, and that's all it takes. That's a great start. So also, I don't really have a very structured agenda for today. I've got some ideas. Definitely going to try to keep it to an hour at the absolute maximum. What I want to start off by doing is by showing off the Bitcoin PR Review Club, which obviously I've just taken the idea. Bitcoin Core PR Review Club has been around for several years. They meet on IRC. They're much more formal. They've got pull requests, scheduled. The meetings have notes about the pull request and questions about it. Participants are invited to look at the pull request and have answers to these questions prepared in advance. And then the meetings are all on IRC. At all levels of knowledge and skill, are provided for. There's no dumb questions. Everyone's there to learn. And in fact, the Bitcoin Core PR Review Club channel on IRC is one of my favorite channels. I ask questions there all the time about Bitcoin, not just during PR Review Club meetings, but it's a very convenient IRC channel to ask technical questions about Bitcoin or stuff about like Linux. And Peter Willa always answers. He's like the smartest people in the ecosystem are in that channel, and you're not bothering them because it's an educational channel, and so you drop a question there and everything gets answered. So that's the kind of community I want to try to create with this pull request review club. I want everybody to come in and ask questions and have a good time and learn something and share, and nobody should be afraid to join. So obviously safe space, and we're recording the audio, but I guess it's probably just going to be for me. And we'll see how it goes. Ideally, I'd like to try to do this every week. Double ideally, there'd be different hosts every week. So if you have submitted a pull request to HSD, HNS, Bob Wallet, anything, Simpapelis, like if you want to share your work or ask for review on something, hopefully this is a channel where we can all do that. So I encourage you to check out the Bitcoin Core PR Review Club, and I'm going to try to get us towards this. Maybe somebody can help me make a website like they have or something like that. Okay, so today's pull request is, well, before we get into that, just to provide for everybody. Oh, and I also want to, by the way, thank you, Fistful of Ass, for helping me organize. You're a great community manager, and for everyone else who's helped set this up. What is a pull request? Okay, great question, Me. A pull request is a change to code that somebody has written and has posted for approval. And so in this case, today we're going to be talking about HSD, which is the full node software that runs Handshake. It validates all transactions, validates all blocks. It provides DNS servers for Handshake resolution. It has a built-in wallet application, so you can send transactions, store your private keys, all that kind of stuff. Hopefully everybody here knows what HSD is. If not, I just explained it to you. This is where HSD lives. It's on GitHub. This is kind of like what open source means, is that the source code is available. GitHub's not the only website where you can post source code. We can do it anywhere. Git itself, GIT, is an application that's decades old and is part of Linux. I think it was written by Linus Torvalds originally. Git is basically a server anybody can host. GitHub has this really nice website user interface around it. And GitHub is owned by Microsoft now. Let's say GitHub is like, we hate Handshake, you guys are gone. We can open up another interface like this basically anywhere. And lots of people already have the code in Git on their computers. It'd be easy to redistribute it to a new location. So this is the code. I'll just click the lib folder here real quick. We'll click the blockchain folder and we'll click chain.js. Okay, so this is a JavaScript file in the HSD code base. This file's job is to validate blocks and add blocks to the chain and handle reorganizations. Pretty important. This is the engine for the blockchain. So just to give you an idea, like this is what the code looks like. If you've never taken a look, you can go to GitHub, you can click around, you can take a look at how the files look on GitHub. Let's say, so now we could talk about pull requests. So if there's something you want to change about HSD, let's say you see, here's a line of code I'm highlighting. I hope you guys can see my screen. I'll try to zoom it in. So this line of code right here, this.logger.info, and then there's something in parentheses, chain height, and it puts the height of the chain into this message, and that comes out when you run HSD, it's printed to the screen. Let's say you're like, I don't like the way this looks. Maybe the word height should be lowercase and not capitalized. That's actually it's actually a reasonable change. If you wanted to change that for everybody, you have this idea like, I want to change the code that everybody runs in HSD. There's something about it. There's a feature that I want that it doesn't have already. There's a bug. There's something about it that I don't like. I want to change something about it. I think everybody should run a slightly different version of the software. That is what a pull request is. You offer a slightly different version of the code. You share it with everybody. People review it, like in Review Club, and leave comments. And then it has to be merged by a maintainer. So this is where it gets a little gatekeepery, a little centralized. The community members with merge permissions are myself, JJ, Boyminya Flambele, who's a little bit retired, and I think that's it actually. I think it's just the three of us. So but if you want to lowercase that H, and I'm like, no, I don't like this pull request, I'm not going to merge it. Like, okay, you can run your own version of HSD where that's lowercase. Lots of people do. Bob Wallet had a different version of HSD for a while. Namebase definitely runs a different version of HSD. You can have a fork, a software fork. It's okay. As long as you don't change any consensus rules, it's okay to have different versions. So just want to get this idea of like open source and contributions, and if you want to change something, this is kind of how it, is how it's done. So let's say you've opened a pull request that changes something about Handshake. On GitHub, pull requests go here. So you go to the HSD repo and you click pull requests. We've got 46 open pull requests. These are ideas to change the code. And they have, you can just kind of see on the screen here on the right, you can see how many comments some of them had. Blockstore was opened June 11th and has 56 comments. That's because it's a very big change, an intense change. It's taken a lot of work. NodeR's done awesome on that, and we'll probably merge that soon. We can find some other pull requests with smaller ones. Okay, so here's a pull request to add another piece of data to an API call. So when you ask the wallet for its info, here, Mike Carson thinks that it should also provide a spendable balance value. And so people are having nobody's left comments on this. Okay, this is another, maybe next week we can get Mike Carson here to talk about this pull request. We can all review it. It might have even been a simpler one for us to talk about today, because I'm just kind of trying to introduce this idea. But we can go to Files Changed, and you can see what Mike has offered to change in the code. There's this thing called wallet RPC. This is part of the API for the wallet. And he's saying, well, why don't we add this extra value, spendable balance, which is just the locked coins subtracted from the total coins. And we'll add that here to the output. Very simple idea. I don't know why we haven't merged this yet. And then he's also added a test. And this is where things get more interesting. So what are tests? Tests are programs that run other programs. It's a way to, like if you write a program, you'll be like, okay, I want this program that adds two numbers together. So you write the program, and then you test it by running the program with values, 3 and 4, and you want to make sure that 7 comes out. And then, okay, my program works. Well, what if that 3 plus 4, make sure that the output is 7 thing could be automated? That's what tests are in this sense. And we also have help from GitHub that runs these tests regularly. And so if someone's like, hey, I want to change this program, I want to make chain height actually lowercase instead of uppercase. And so you do that, and then GitHub will run these tests, and it'll be like, oh, you know what? You changed the capital H to a lowercase, but now for some reason, 3 plus 4 equals 8. All right, so the test has indicated that there's something wrong with your pull request. That's a huge reason why we have the tests, so that to prevent regressions. In fact, they're basically called regression tests. So every time, we have a lot of tests in place already. We definitely want to have lots of tests for the consensus rules. So if someone's like, yeah, I want to add this pull request that changes something, we can run the tests that we have at least and make sure that the new pull request doesn't break something that we know already works. And so kind of a rule that we have when you're contributing to Handshake or open source in general, you might say, is that when you offer a pull request like this, Mike wants to add spendable balance to the wallet API, you should also provide a test. And so that's what he's done here in this, really it's down here. So basically he wrote a test, a small program that opens HSD and goes through an auction and sends an open for a name and bids on the name, and then checks the wallet info and makes sure that there's a spendable balance datum there, and that the value is correct, the lock balance subtracted from the total balance. Okay, so pausing for questions. At least one person, please give me a thumbs up in the chat or something to make sure that we're all on track. We're talking about open source. We're talking about where the source code is located. We're talking about what a pull request is, and we're talking about what a test is. Anybody got problems with any of that? Has anybody learned anything so far? Just somebody give me some kind of feedback in the chat before I go on. Or yes, the other thing I'll say, I see that Jesus is typing something. The other thing I'll add, okay, great, thanks guys, is feel free to turn on your microphone and just talk. The caveat is that we are recording, your voice may be recorded. I know the AMAs are usually one host with people chatting. That's fine too. But if you have a question, turn on your mic, just yell it at me. Ideally, as we do this weekly, like it turns into more of a discussion, and like I showed you in the Bitcoin Core PR Review Club, they have questions that they go through, and the host will sort of expect the participants to have answers, or we can like ask further questions, stuff like that. Okay, great. So actually, I'm thinking this might have been an easier pull request to review, and I'm wondering if we should do this. Let's take a quick poll. Should we switch the plan? Forget the complicated pull request I had about checkpoints. Do you guys want to talk about checkpoints, or should we talk about something like this that is just a little bit easier to understand, a wallet pull request? Just one person answer me, checkpoints or wallet? Looking for one word in the chat. Great, thank you. Okay, checkpoints it is. So the pull request that I had scheduled to talk about today is this one, number 629, opened by Pinhead MZ, increase text coverage for chain. I didn't do a great job explaining what this pull request does here. I could have done a better job for more, I guess, first-time contributors to understand the pull request. I don't think anybody has commented on that. I've made another comment here. Okay, so I'm going to explain to you what this pull request does, and then we'll dig into the code a little bit. The reason for this pull request is because recently we merged this other pull request by JJ called Fix and Enable Checkpoints for Mainnet. He says work in progress because he hasn't tested it. So I tested it locally. Falchi had some questions about it. JJ was unable to answer, but I got in touch with JJ and figured out some of the answers to Falchi's questions. And so you can see there's some comments here. Brandon D's left a comment, has looked at the code. I left a few more comments, and then finally I left this ACK with a signature because I'm a crazy nerd. So ACK means acknowledge. There's other things, other quick messages you can leave like this. For example, if I do not want to merge this pull request, I could have said NAC with an N. Bitcoin Core, people also like to use other words like UT-ACK, which means untested ACK, or like concept ACK, where like they like the idea of the pull request, maybe haven't tested the code, that kind of thing. So any kind of response you can add is good. This pull request has been merged because I did the tests myself. I talked to JJ about it in person. I understand the changes, they're good, they're safe, and we merged it. But JJ did not add tests to this pull request. Bad contributor, bad JJ, bad contributor. So I wrote the tests for him, and that's the pull request we're going to be talking about today, or at least part of it. Great. So here's the front page of the pull request. We can look at the commits. We can look at the checks. These are the tests that that GitHub runs whenever you submit a pull request. And finally, the good stuff is to probably actually look at files changed. So this is what JJ actually did. And now I will explain what checkpoints are. So if you look at this area of the code here, what JJ has done is hard-coded certain block hashes by their height. So, if we want to trust, let's say, hnsnetwork.com, we can go to block 1008, and hnsnetwork.com says that the hash for block 1008 is this string here. It ends with 8953E, and we look back at JJ's code, and here it is, 8953E. So, so that's important to understand. A checkpoint is merely a hard-coded height and hash pair. So what this means, once the checkpoints are in the code, is that the node, full node, when you boot up HSD or Bob Wallet for the first time, it downloads the entire blockchain. That's how it gets the state of the system, the root zone and the coin ledger. What the checkpoints rule means is that if a peer offers me a block at height 1008 that does not match this hash, that block is invalid. And I think the peer might also get banned. So that's kind of interesting because that doesn't really it seems a little centralized-y for anybody to say that a certain block at a certain height has to be this block. Like, isn't the whole point of blockchain that like the system sort of figures itself out? Why are we hard coding these blocks at these heights? I have two answers to that. Good question, me. The first answer is checkpoints are optional. You can run HSD with checkpoints false, and it'll just completely ignore the list and accept any block at 1008, at height 1008, just so long as eventually it ends up on the chain with the most accumulated proof of work. Now, there's more advantages to running with checkpoints on, which is where we're going. And I guess we can do that next. Yeah. So checkpoints. Oh, okay. The other thing. So yes, it's a little centralized-y, but you can always run with checkpoints off. It's easy. It'll just take you longer, and I'll explain why. The other thing is that these heights are very, very old. So the last block in this list is 61043. Let's go back to my friend HNS Network. Of course, you'll be doing this with your own full node, but for now, it's just quicker to use a web browser. So block 61043 was mined on March 29th. That is, 6 months ago now. What is the probability that the block at height 61,043 will change? What it would require to change is a reorg, a chain reorg that is 6 months large. I think we're up to somewhere around height 80,000 now. Where are we? We're 85,000. Okay, so for this height, this block height to not be this block hash, some miner would need to have the most epic of all 51% attacks sustained for such a long period of time that they rewrite the last 6 months of the blockchain, and then they can undo this block and replace it with a different block. If that happens, we're so fucked. So it's safe to assume that a block that is 6 months old will not be changed. Now, blocks within the last 2 days, I would not want to do this, because we could have a reorg that is 6 hours long or a day long or 2 days long. It starts to get very scary and means incredibly devastating implications about the health of the handshake network to have a reorg that big. But I think we can all agree that this block that is 6 months old is not going to get reorged. So we might as well hard code it, and that's what we're doing here. Okay, so Fauci and I have discussed, I have a little piece of code here. So one great way to review JJ's pull request is to simply check with your own full node that these heights match these hashes. JJ is asserting that the blocks at these heights have these specific hashes. Well, before we merge this into the code, someone's got to check that. If you have a full node, you can run this command right here. It's in bash. It's just the list of heights JJ provided. I use an HSD API command to get the hashes, and I can just look at them. Yes, these hashes, or you can use HNS network if you want to trust them. So I've confirmed that these hashes match these heights. It would be great if everybody did that. Everybody in this room. Here's the bash command you can run in your full node. You can make sure that JJ's not trying to add an invalid block in there or something like that. And then the last part of this pull request that is important is the last checkpoint, 61043. And this is where things start to get really interesting. So as a node is downloading blocks, this is a recap, as the node is downloading blocks, whenever it hits a block at this height, it makes sure the hash equals the hard-coded checkpoint hash. And if it doesn't, the block is simply not accepted. It's as if the block is invalid for any reason. It exceeds the maximum height requirement. There's an invalid signature. It's just a consensus. Well, it's not a consensus rule. It works like a consensus rule. Your full node will reject it because again, it's kind of an optional consensus rule. Like I've said, we're pretty sure that that's correct. Okay, so the last checkpoint is at height 61043. That matches the number that is up here. Here's where things get interesting. So, and this is what checkpoints are for. As you are downloading blocks from peers for the first time that you run a node, you've got to eventually download 85,000 blocks if you're syncing a node right now. If the block you are downloading is below this height, 61043, get this, you do not verify cryptographic signatures. I'll repeat that. As you're downloading blocks, the first time you start an HSD node, if the block you are downloading is below this height, 61043, you basically don't validate the block. You still update the Urkel tree, although we need to optimize that. You still update the Urkel tree. You still update the UTXO set, obviously, because this is consensus critical. But basically, you just assume that every transaction in the first 61,000 blocks, you assume that every transaction is valid. You don't check it. So it's an optimization. It's a time-saving mechanism. And like I said, since 61043 happened 6 months ago, it's so unlikely that a chain reorganization will actually change the outcome of those first 61,000 blocks that we can assume that it's safe to not validate transactions below that height. That's critical. Is there anybody not understanding that? In one sentence, the point of checkpoints is to speed up initial blockchain download by assuming transactions are valid. That way we don't have to spend the computational resources to check cryptographic signatures, which is hard and takes a long time because there's elliptic curve math and everything like that. One person, just say okay in the chat or give me a thumbs up or an emoji or the Pepe smoking a joint emoji or something. Somebody just tell me that we're cool. And if you have a question about what checkpoints are or anything. All right, thank you, Handshake Jesus. Okay, so I think we can move on. So JJ's pull request adds checkpoints for basically the first time in Handshake's history with the intention of speeding up blockchain sync. So JJ did something else with his pull request too. He actually changed a little bit of the code, which is interesting. And it turns out that Handshake had a bug in the checkpoint processor where if we had started using checkpoints without this change that's on the screen now, consensus would fail. And if you were running a node with checkpoints enabled and you were using these checkpoints I have here, you would actually end up with an invalid consensus state and we would have a hard fork on the network. So it was a really good idea that JJ looked into this before enabling checkpoints. And I'll explain briefly what his change is, and then we'll finally move on to today's real topic, which is my pull request adding a test to prove that JJ fixed this bug. So I'm actually going to not try to explain his code. What I will do is switch to HSD now, and I'm going to go to change.js, and I'm going to look for this line here. So verify context is a function in the blockchain validator in HSD that checks basically all the consensus rules. So if we, this function verify, here, let's go look at verify real quick. What does verify do? It makes sure that the prev block, the previous block exists, that we're in a chain. Let's find some other stuff here. It makes sure that the maximum amount of opens and updates is below the limit. It makes sure that the proof of work is correct. I mean, that's crazy important. It makes sure that the timestamp is correct in the block. It makes sure that the soft forks are deployed correctly. It makes sure that the witness is the right size, that the airdrops are valid. I mean, there is like probably no more critical function in the entire code base. Can't see terminal, just browser. You should be seeing my IDE now. Let me try. I've had this problem actually. Stop streaming. Do this again. Yeah, I've noticed for some reason. Okay, so are we seeing my IDE now? You guys are seeing Sublime Text, seeing the code? Great. Okay. So if you missed it, I was just briefly breezing through this function verify in change.js and just saying how like it checks all the rules in the block. It's super important. Okay, so that function is called up here, and this is where things get relevant. So this section of the code, after we check a bunch of stuff in the block, like that the proof of work is valid, and that a bunch of other rules are followed, like sizes, before we get to the that's the first thing we do. We're verifying a block. Verify the easy stuff. I'm going to skip the highlighted section for a second, and then this function, verify inputs, verifies the hard stuff. This is the function that actually checks the transactions. Here we go. We're checking all, it says right here, this comment, checking all transactions. Make sure that the airdrops aren't double spends, making sure that transactions aren't spending more money than, aren't generating more money than they consume, verifying that all the auction covenants are correct, all that kind of stuff. It's a lot of work, critically important. Okay, back over here on the left though, we have this little if statement. And the comment says, skip everything if we're using checkpoints. This is actually not entirely correct because we're not skipping everything. And we use the thing is historical. And I guess I can briefly show what is historical does is it makes sure that we're using checkpoints, and then it asks what the last checkpoint is. So if you recall in JJ's pull request, he set last checkpoint to this value 61043. So long story short, what we're doing here is what I explained kind of in the opening. This is the part of the code where if we're validating a block and the height of that block is below 61043, we're going to do something a little different. We're not going to call verify inputs, which does all this hard work. We're going to call this function update inputs. Let's take a look at that instead. All right, the comment here says spend and update inputs, checkpoints only. That's critical because this function does not verify every part of the transaction. I'll just summarize what the code is doing here. It's basically just assuming all the transactions are valid, that all the scripts are valid, that all the signatures are cryptographically valid, and updating the UTXO set. So, if a transaction spends a coin and creates 2 new coins, instead of actually looking at the script and making sure things are correct, we assume it's correct, and we modify the UTXO set accordingly. Destroy the coin that's being spent, add the 2 new coins. So we update the ledger without actually verifying anything. Again, I'm assuming you guys are all following this, or I'll get a middle finger emoji in the chat or something like that. Okay. All right, this is going really well. So now I need to explain what the bug was and what JJ fixed, and then we'll have half an hour to actually talk about the actual pull request. So I'm going to do a quick trick here, enable checkpoints. Because if I switch back to GitHub, I think you're going to lose my screen. I have this, this is how I like to review pull requests. So I have my text editor set up in a certain way that I can make it look like GitHub, where the code changes are side by side. And maybe I'll show this on GitHub first. So here, this is probably going to ruin my screen share. So I'll go back to GitHub real quick. Okay. So here on GitHub, you'll notice that this is something I forgot to mention about how pull requests look on GitHub. The left side is the original code, and the right side is the new code, the proposal. And you can, probably assume that like the red highlighting are lines that are deleted, green highlighting is lines that are added. GitHub actually offers a preference. Some people like to look at pull requests this way, unified. So you can see the red and the green, it's all stacked in one long column. And so like this line is deleted and this line is being replaced. I have a preference for the split view. It's totally up to you, however you like to look at it. I prefer the split view because the left is the complete original document, the right is the complete new document. And so it reads like code. If there's lines in the middle, it gets distracting to me. So this is how I like to look at pull requests, is the side by side. Okay, so now I'm going to switch back to Sublime Text, and I will swap my screen share. Okay, so when I'm reviewing a pull request, I didn't teach you guys how to actually pull a branch locally. We'll have to build up this kind of talk as we go through these meetings, I think. But so I have JJ's pull request locally, and I can analyze it with my own software to make it look the way it does on GitHub, so I can see the two things side by side. Sorry, that's should have prepared a little bit better for that. So what JJ's change really does here is it includes the Coinbase transaction. This is kind of interesting because this code originally, like the code on the left, is how it looks in Bcoin. It's how it looks in Bitcoin, basically. We still, this is the update inputs function. So this is the function that we run when we're under a checkpoint. We have a block that's under the last checkpoint. In Bitcoin, the only thing you need to worry about is the UTXO set. You don't need to, in Handshake, we have the names, right? You got like the name auctions and the name state, the state of an auction and who owns a name and what the DNS records are for that name and all that kind of stuff. Bitcoin doesn't have to worry about that. Bitcoin just has to worry about transactions, coins moving, the UTXO set. So for this reason, the Bitcoin side here on the left, it treats the Coinbase transaction in a special way. The Coinbase transaction is a special type of transaction added by the miner in every block. It has to be the first transaction in the block. You can see TX is 0 here. It's required, and it has some special properties. For example, it allows the miner to generate new coins. I think we all understand that miners generate coins. They do that by adding a very special transaction to the top of every block that does that. So if we're below the checkpoint, if we're Bitcoin and we see a Coinbase transaction, all we need to do is add the output of that transaction to the UTXO set. Okay, the Coinbase transaction just generates new coins. We just add those to the UTXO set, skip everything else. The problem is, in Handshake, the Coinbase transaction has a few extra properties. For example, that is where reserved name claims go. And it's also where airdrop proofs go. Airdrop proofs are basically just like mining new coins. There's nothing really special about that. But reserved name claims update the Urkel tree. They update the name state. They do something that is not just the UTXO set, So we need to handle it in a slightly different way in Handshake. And what JJ has done with his code change here is he's added, he's processing the Coinbase transaction in a way that he wasn't doing when it was just Bitcoin. And you can look at his code and see that over here. He is, lost screen share. Sorry about that. Try that again. Thank you for letting me know. Put this back. Is that better, Dees? Not sure why that keeps happening. I lose my screen share when I'm doing video chats. Your stream currently has reduced video due to network conditions. Let me try turning off my camera. All right. Let's just push forward. I think we're being recorded anyway, so Okay, thanks for the feedback, guys. I'll just push forward. So the code change here is, you can see on the left this loop that goes through all the transactions in a block. In Bitcoin, it starts at index 1. In Handshake, we start at index 0. That's how we include the Coinbase transaction. So that's what JJ's doing. He realized that for checkpoints to work properly in Handshake, we actually need to do a little extra processing on the Coinbase transaction to catch those name claims. So let's pause for a minute and think about this. What would happen? Try checking the list. Maybe it's somewhere different, or maybe okay. What would happen if we did not process a name claim in a Coinbase transaction of a block? Well, what would happen is when that, after 30 days, when that reserved name claimer went to register the name, the node would see the name as being unclaimed. They would have an empty name state. And so the register would be invalid. So some nodes who were not, who didn't have this bug, will process the claim, and then 30 days later process the register, and it's valid. But if we left this bug in the code and added checkpoints, nodes would get to that register, and there wouldn't be a corresponding name claim. So that block would be invalid, and that's why we have consensus failure, and everything gets really nasty. All right, so JJ fixed this. And I'm going to prove to you that he fixed it. And here's where we are finally getting to the pull request. Okay, so let's see. This is a little bit harder. Oh, you know what I can do is I will show you the test that I wrote, just the whole file. So my pull request, the one that we're reviewing today, adds this entire file, chain-checkpoints-test. It does a bunch of other stuff, but like I said, we're just going to focus on this. One of the other things I noticed, I think I could probably show you real quick, is that the yes, some of the stuff was just like there was. I just want to try to find the to-do in here. Maybe I can't find it. It's all right. We'll just talk about it later. I started just doing this one test, and I realized there were a bunch of other tests that JJ had kind of removed when transitioning from Bitcoin to Handshake, and just put a to-do. And I'm like, well, okay, we can do that too. That's why my pull request ended up getting bigger. But this is the commit we're going to talk about today, the test, the checkpoints test. So what I wanted to do is quite simple. I want to generate a blockchain locally in a testing environment, a test blockchain, with a bunch of transactions, a bunch of name auctions, some name claims, some airdrop proofs, basically like, every type of transaction I can think of. Build that chain. Then I'm going to create 2 HSD full nodes, one with checkpoints on and the other with checkpoints off. And I'm going to sync both of those to that chain that I created in step 1, and make sure that the checkpoints node and the without checkpoints node sync and don't have any failures. So before we go into the code, I'm going to actually try to run this. So I'm going to, again, yeah. Let's go back to this. Okay. All right, so you guys can see my terminal now, I hope. We're on my pull request branch. So what I'm going to do is I'm going to run that test. And how you run a test in HSD, there's 2 commands that you could get to be familiar with. One is npm run test. This is going to run through all the tests in the entire HSD suite. You see we're looking at auction RPCs, we're looking at the block test, the checkpoints test, here come Nodar's chain migration tests, pruning the chain, all this kind of stuff. The tests take a few minutes, and it'll run everything, and hopefully without any failures. The other thing you can do is npm run test dash file, and then give it a specific file. Whoops. So I'm going to run one test, just the file that I added in my pull request. So if you're reviewing my pull request, you want to make sure this test works, you can just run this one test instead of running the whole test suite. So let's run it. All right, and let's take a look at this output. Add addresses to the miner, mine some blocks, add a claim and a register, send coins to an unspendable address, send coins to a regular address, go through a name auction, do some airdrops, and then confirm some more blocks. And then I do, so this is like the setup phase, like I was describing, these actions, these things. And then finally comes the real test, which is syncing two nodes with checkpoints and without checkpoints, and they both work. So now let's do something a little bit more funky. I am going to quickly prepare a a demonstration, which I should have done at a time, but I just did. So we'll go down to here. Okay, so did this work? I think so. All right, so what I showed you a second ago was running the tests on top of JJ's bug fix, and all the tests pass. Wonderful. What I'm going to show you now, I think, if that command works, maybe it won't, probably will, hopefully it will, is what I've done is I've reverted JJ's bug fix, added my test back, and now I'm going to run my test again, and let's see what happens. Okay. The first test failure, that's because my demonstration was not good. And the second test failure is the important thing. So the node with checkpoints, sync with checkpoints, failed at height 204, and the comment there says register reserved, database inconsistency. This is the bug JJ fixed. If you were syncing a node with checkpoints before JJ's bug fix, you would get this error, database inconsistency, while syncing. Holy shit, that's terrifying. And you would get it actually. eth.ens.domains, the name claim for the handshake tld.eth was not the very first reserved name claim on Handshake, but it was actually the first reserved name claim that registered. And I forget what block that is. I have it written down in the comments. Actually, maybe I could switch back to that and show you. Are you guys seeing my browser? Can somebody tell me yes or no they see my browser? Can't see it. Okay, yeah, it's weird. When I switch applications, the share screen thing doesn't really work. Let's go back to the browser real quick. Okay, hopefully you see the browser now. Andy R16, can you give me a yes or no?
See it.
Okay, wait, thank you. Okay, so here's a comment that I left as I was reviewing JJ's pull request. Basically, I ran a node with checkpoints enabled with and without his pull request. This is what I did before actually writing the explicit test. And I got the database inconsistency error on the register for ETH, this transaction right here. When ENS domains actually registered the .eth TLD that they had claimed, I got an error, and that makes sense based on everything I've explained so far, right? The reason that that sync failed with that bug in place is because my node had skipped the transaction validation that added the ETH name claim to the Urkel tree. And so when I finally got to block 14458, my node saw the register for ETH, but that was an invalid transaction. Crazy, right? So this was a good bug fix. I'm so glad JJ did it. Okay, great. So does that make sense so far? One person, give me a yes or no. Basically, you guys understand, hopefully, that there was this bug where we understand checkpoints now. Checkpoints mean we don't validate everything. The bug was that in addition to not validating everything, we also skipped over a very important step, which is to update the Urkel tree when a reserved name claim is confirmed. We skipped that, which means that when that name gets registered, there's a consensus failure. Does anybody not understand that? Please feel free just to turn your mic and say, I don't get it. Ask a question in the chat. Don't be shy. Anyone got anything to say?
I'm with you.
Yeah, buddy. All right. Thank you. Okay. Sweet. So let's talk about, and I also hopefully have demonstrated the pull request that we're looking at today, the test that I added, that I prove that, well, at least when you run my test without JJ's bug fix, the test fails. And when you run it with JJ's bug fix, the test passes. So let's do the fun stuff. Finally, the moment you've all been waiting for. How does this commit actually work? What do we actually do? And so we're going to talk about how I'm going to go to Unified for this. I'm just going to stay in my web browser for now. We're going to talk about adding tests and pull requests and like that. So, you know, the kind of the neat thing about this pull request is it's just adding a test. It's, you know, Mike's wallet pull request that I showed earlier. He actually is changing the code and wrote a test to prove that his code works and to prevent regressions. All I'm doing is adding a test. JJ could have added this test in his pull request, but you can also just open a PR that is just a test. And in fact, if you are interested in dipping your toe into Handshake development, I would encourage you to start by adding a test. And I got tons of ideas. There's tons of stuff that needs to be tested. Basically, you can just test any API call. Test getInfo. Make sure that getInfo works. You know, there's a lot of API calls that we don't have tests for. All right, so this is what a test looks like. I added this entire file. And so this is where we're going to get a little technical. Some of you who don't understand JavaScript or aren't coders might lose you a little bit, but I'm going to try to keep us together here. So I'm going to skip over stuff that kind of doesn't matter. Remember, the goal of this test is to generate a chain with lots of different transaction types, especially including a reserved name, claim, and register. Then I'm going to feed that chain to a node with the checkpoints on and make sure that it syncs. All right, here we go. So the first part of this file just sets up a bunch of shit. We, you know, create a chain object from the HSD library. What's also interesting about this test is I'm not running nodes, actually, even though I've used that term. I'm just concentrating on the chain module. This is an interesting part about HSD, that it's a library. So you can imagine, like, instead of taking a car for a test drive, you like are just making sure that one of the pistons goes up and down. You know, really just focusing on one unit. Okay, so just looking at the chain. I don't need the RPC module. I don't need the wallet. I don't need the networking stuff. I just need the part of the code that validates blocks with and without checkpoints. That's all I'm going to test here. So I need a chain object, and I need a miner, which is the part of the code that generates blocks, obviously. One thing that's interesting about this is I wanted to, every block that I add to my test chain, I added a label, and I did that by creating an array, so that when the test fails, I'll know why. I'll know specifically what happened in that block. So when I showed you the test failure, remember the error message said register reserved. That's a comment that you're going to see in this file, and the checkpoints test failed on that block, and I know it was the register reserved block because I labeled it. So I'm going to keep track of every block I add to the chain. And so I have a function to add blocks to the chain. And here we go. So the first part of this is we're just going to add blocks to the chain with a bunch of transactions. Mine 200 blocks. And then this little chunk I'm going to is the good stuff. This is the claim and the register. So I have a line here to add a reserved name claim, add that claim to a block, fast forward the blockchain through the claim period, which would be 30 days, and then add the register. And here's the register reserved comment that we see in that error message. So here I've added a registered name to my chain, added some blocks, and then added the register. Nodar says, I believe it was only Coinbase Transaction that was not being processed by verified covenants that reproduce unique Coinbase Transaction with claim, for example. That's absolutely right. And that's the first block I have here. But to be, so Nodar's correct that the only bug fix I really needed to cover was a Coinbase transaction with a claim and a register. But I went all out and just made sure that there were no other regressions and covered as many transaction types as I could think of. And that'll also prevent regressions in the future in case somebody adds a pull request that does something to checkpoints and now maybe reveals don't work in checkpoints or something. Just might as well cover everything. Here's another one, you know, sending outputs to a null data address. This is a UTXO that's unspendable. That's something we want to make sure that works, you know. Regular transaction, just sending money to an address. Let's make sure that works. And all these transactions are being added to blocks. Here, thank you, Nodar. Here is a whole auction in a test. These you know, whatever it is, 20 lines of code. actually runs several auctions. I'm using the wallet to send an open for 3 names. Then I mine a block with those opens. Then I send bids for each name. Some of the names have 2 bids. Some of the names have only 1 bid. So that they have a 0 value name and a name with a value. I send the reveals. I send the register. All these transactions are going into blocks. So if you guys understand, like this little test program is generating a chain that looks like a real mainnet chain. It's got transactions in it. It's got auctions. There's a wallet involved here that's signing transactions and should work like a real chain. Here's an airdrop proof. This stuff is kind of fun. Adding an airdrop proof to the chain and then add some more blocks. So at this point, we're almost on line 200. I've generated a chain object. I don't know how many blocks long it is, maybe 500 by now. And it's full of different types of transactions of all the different types of transactions I could think of. If you think this is a type of transaction that I've missed, open a pull request, or add a comment in here. There's another thing. If you don't like something that you see, you can leave a comment here on GitHub. This part sucks, and then add a single comment, and that's how you review a pull request. If anybody in here does this, add a comment to this pull request, positive, negative, whatever. Just try it out. Leave a comment on the pull request. This is how you get involved. Ask me a question. I don't understand why you put mine blocks here. Why do you mine 10 blocks and not 20? Ask me. I'd love to answer that question. Find a problem with my pull request. Maybe I left a bug in here. Let me know. Add a comment, and we'll send some HNS around. All right. So we're moving forward with this test. We've generated a chain with a bunch of transactions. Now I'm going to feed that chain to another chain processor with the checkpoints disabled. So here we go, line 198. I'm creating a chain object just like I did in the beginning of the test. This one is empty because it's brand new, and I'm specifically saying checkpoints false. And then very simply, I take blocks from the chain that I generated and add them one at a time to the new chain and make sure that they do not throw an error. And at the end, I make sure that the chain states are equal. Chain state, make sure that the height is the same, that the hash of the chain is the same, that the proof of work on both chains is the same. Everything should be the same, especially without checkpoints, because this is just how a regular node syncs. Brenda D says, is there any point during this bug scenario where a reorg could impact the outcome? Can we simulate a reorg in a test setup? That's actually a very good question. There are other tests to handle reorgs elsewhere in the code base. But also, I think as Nodar is explaining, like there are no reorgs before the last checkpoint, because remember, like those first 61,000 blocks are basically hard coded. So so they don't, there cannot be a reorg while we're under a checkpoint. Do you verify the Urkel tree output as well? Basically, yes, I do. I don't actually request the names from the Urkel tree, like request DNS resolution, which might be what you're asking. I could do that. The reason I don't bother with that is because the hash of the Urkel tree root is in the block header, right? So when I'm done with this test, I build up a chain, I copy all those blocks one at a time to fill up the test chain, and then I look at the block header on the top of the test chain, and it should match. It should match the height, the hash, the prev input, the Merkle root, and the Urkel tree root. So simply by verifying that I arrive at the same Urkel tree root as I did when I was generating the chain, we can assume that the name state is the same. Yeah. Okay. Good. Yeah. And there are. This is the other thing. There are other tests in the HSD library that add names to the Urkel tree and then request them back. So like I don't really need to cover that here. All I really need to make sure is that the blocks are in sync, the block headers have the same data, and yes, I do make sure that the Urkel tree is the same just by testing the tree root. And then there are other tests around HSD that make sure that the actual names and the name data is there. Okay. Anyway, so we sync the chain without checkpoints. Checkpoints false. I feed the blocks one at a time with a for loop from the previously generated chain to the new chain, and then I test that the tip matches. And I do the exact same thing with checkpoints true. That's the only thing that changes. not only do I have to set that checkpoints are true, I also have to add a checkpoint, right? Because this chain is being generated basically randomly on your computer every time the test is run. It's in a local testing environment. And so you can't hard code checkpoints the way JJ does in his pull request. So that's basically what I'm doing here is I generated my chain, looked at a block towards the end, and just kind of forced that into my test chain as a checkpoint. Basically doing what JJ did in his pull request, hard coding a block height. I just did that here. Yeah. So I'm going to switch back to terminal just in the last couple minutes and do one more. Actually, here's what before I do that, I'm going to check out. Give me 1 second here. Only got a few minutes left. Okay, so here's what I'm going to do. You guys can still see my my web browser. And I'm going to tell you what I'm going to do without screen sharing it, because otherwise I'll have to keep switching, and then I'll show you. So this loop here, it should sync chain. I start at height equals 1, because remember the genesis block is 0, so we don't need to add that. We get that one for free. I start at height equals 1, and I go all the way through the chain generator dot height. So I go through all the blocks in the generated chain. I get the chain generator height with this right here. So I'm going to get all blocks in the chain from 1 to the tip of the chain of the generated chain, add them one at a time to the test chain, and then make sure I ended up at in the right place. So what I'm going to do now in this demonstration, you can't see my IDE, but I'm going to change this. What I'm going to do is, instead of going all the way to the tip of the chain, I'm going to stop 1 block early. So we're back to my terminal now. I've just done a git diff to the screen. So what I've done is, instead of going through every block in the generated chain and adding every block from the generated chain to the test chain, I'm going to not add the last one. Who knows what's going to happen? Somebody tell me. Somebody just write something in the chat. Tell me what's going to happen. Turn on your mic and tell me what's going to happen when I run this test. Anybody, give me a middle finger emoji or something. Somebody give me something. Thumbs up, thumbs down. Is this test going to pass or not? Almost out of time. Somebody tell me, thumbs up or thumbs down. Is this test going to pass?
So I got distracted, but I assume this should fail because you're going to end up with a different chain state, right?
Hell yeah, that's totally right. Let's try it. Look at that. This test failed because I ended up with a different chain state. The test chain does not match the generated chain. And the test suite shows us the differences between the expected value and the actual value. So, we're missing 1 UTXO. That's probably the Coinbase output of the last block. The tip is a different hash. The number of transactions on the chain is different. The value of the amount of coins on the ledger is different. And this is just one of several tests. Basically, as soon as a test fails, it just stops. I actually have multiple assertions that check everything, like the tree root, like Deez was saying. The tree root would also, if we had gotten further, if this line had somehow passed, we would still get caught at the tree root test. So, that's great, right? Like, when you're reviewing code, especially if you're reviewing tests, I encourage all of you to make the test fail. Do what I did. Look at something like a for loop and just subtract 1, Or when something says like, oh, I'm making sure that the wallet balance is exactly 2000 HNS. But what if it's 2001 HNS? Does the test fail? Why does it fail? This is a really great way to review code. Or if I wrote a test let's go back to like Mike's pull request, where he is adding a wallet balance to the API and then tests to make sure the wallet balance is correct. Well, if you go into the wallet code and add a +1 here or there, add a bug, create a bug, delete a line of code, just delete something, add a +1 somewhere, and the test still passes, that's a problem. That means it's not a good test, right? So it's a great great technique, what I just showed you. Like if you're reviewing a pull request, make the test fail, either by breaking the test or by going into the code and breaking the code. And I've shown you both of those, right? I broke the test and the test failed. I also added JJ's bug back in and the test failed. Then I took JJ's bug back out. I applied his fix and the test passes. And I take out this -1 and the test passes. This is just a great way to review code. And that's it. That's it. We got 10 seconds left before 10 o'clock Eastern. What do you guys think? Comments, questions, any feedback? What do you all think? Any questions about reviewing pull requests, about open source, about checkpoints, about the bug, reserved name claims, anything like that?
I just want to know, with regards to this particular PR, is there anything that you still feel uncertain about that we could like put more thought or more hammering into to sort of build up more confidence? Like do you feel like there's anything that may have been skipped over, or any like possibility, variations that might not be, well proven yet? That's what I was asking about the reorg thing. Like is this test affected by anything that can happen like at a point in time in the past or whatever that like this test wouldn't account for?
Right. So my confidence is high that JJ's bug fix is correct. I wrote this test that gives me explicit confidence. I've also synced a node with and without JJ's bug fix and have observed it working. That's why I approved his pull request and merged it. That being said, like this shit's complicated. There could still be something that we missed. The reason that I didn't just write a single test for the reserved name claim bug below checkpoints. I added a full auction and an airdrop proof and a null data address. Because I was thinking exactly like you are right now. I'm like, well, wait, we missed this. Like, JJ found this one fix. What else could be wrong with checkpoints? That's why I tried to make the test as explicit as possible. So, question about reorg, like a reorg below checkpoints would be basically like this: that like let's say we get an alternate block that forks off below the last checkpoint height. And actually, there is a very specific test for that already. That was added by Braden Fuller in Bcoin like 2 years ago. But we copied that over to Handshake. And we have tests for reorgs. Could I have added a reorg test here? I think that the reorg, the alternate before last checkpoint test I just described, added by Braden, I think that covers it. But like that question, again, for everybody who's in the meeting, like Deez's question is a great thing to just to add on GitHub. That's pull request review. That's participating. No one's going to call you dumb, whatever. Like it's a good question. So thank you for that. And I encourage other people to ask questions too. Anyone else? Is there any grunt work that a beginner, less technical person like me could contribute to? Yes. So for new contributors, people who consider themselves beginners or less technical, there's 2 really good ways to get started. The documentation always needs work. In fact, let's go back to the web browser real quick, and I'll show you some ways that you can help. So if you're familiar, API docs, right? This is the documentation for HSD, the HSD API. Supposedly all the commands that you can ask HSD are listed here with an explanation. There's a lot of things that are missing. There's even some things that are incorrect. This documentation website itself is open source. I've got it bookmarked, of course. This is the repo, handshake-org.github.io. It's in the handshake.org GitHub zone here. I'll put this in the chat. This is the source code for the API docs. So one great way to get started, and by the way, what I'm about to say, this is the very first thing that I did for Bcoin. When I got hired by PRRC in 2018. I was not a very good programmer yet. I just knew how to use Bitcoin. I just knew how to run it. I wasn't that familiar with the code. I could run it. I could make these API basically just run commands. And some of the commands, were not documented well. And my very first job in Bitcoin was to update the documentation. Let's take a look at a pull request for, this user KQZZ 2 weeks ago opened a pull request because there was something missing. Like this one example in the code for RPC get name info, the example in the code didn't work. And this person asked me on Discord, yeah, I don't think this is right. And we look at the documentation and we're like, oh yeah, it's missing this double quotes. So they opened a pull request to fix the documentation. Great stuff. Really, really, really good. You're just writing in English. This is basically, it's a markdown file. It's not even HTML, it's just markdown. And this is a huge help, and I'll need to review these and merge them. So if you can run HSD and run commands, and you think the documentation is wrong, you can open a pull request to change the documentation, which is great. If you feel like doing something a little bit more advanced, like I said, a great thing to do is to add test coverage to HSD. So there's a couple ways to see like what test coverage is we have and where we need test coverage. I'm going to go to this file node RPC test. This is a file.
I'd like to elaborate on that and say,
yeah.
even if you aren't comfortable writing these type of tests because they are complicated, just write out the idea for a test, right? Like write some notes about a test that could be added in English, and then we can have a discussion about it and get it added. That's still a useful contribution.
Totally, thank you. And you can open an issue with that or send anybody a message or something. What I was going to show you, this file node RPC test.js runs RPC commands. We create a full node, and then we do things like run generate to address and make sure the output is correct, and then we run get block and make sure that we get the right block, and then we run validate resource and we make sure that the output is correct. And I guarantee you there are API endpoints that are not covered in these tests. This file is way too short to have all the RPC commands covered. So, pick one. Let's pick one. Let's go to the API docs. Let's go to RPC get net totals. Okay, returns information about used network resources. It's an RPC call I've never used before. I guarantee you, there's no test for this. Write a test for get net totals. Get it in there. Get network info. Okay, this is a command that I do use regularly. I don't think we have a test for it. Add test. Really easy pull request. Great way to get started. And maybe next meeting or like offline in a chat or something, we can talk about how you would write a test. Basically, you just ask the full node for get network info, and you want to make sure the output basically looks like this. Recently over in Bitcoin land, I had some students helping us add test coverage to Bitcoin, and I told them the same thing I'm telling you guys now. We added some tests. I'm going to go back to my split view. We added some tests to Bitcoin. One of the things we realized was not covered is RPC command get chain tips. Get chain tips. It tells you how many chain forks there are. And so the student added this test where we generate a forked blockchain, and then we ask the full node get chain tips, and we expected to get 2 chain tips back because we had provided it with a forked blockchain, and we just make sure that call is correct. So I told them what I'm telling you guys now. If you're getting into a code base, the best place to start is the documentation. Once you're cool with that, you want to move past that, do something more advanced, start writing tests. And then, once you feel comfortable with that, you can start fixing bugs or adding features. Nice. All right, so we're a little bit over time. I think I'm going to wrap it up. I'll be on Discord all day. You guys feel free to ask questions in the HSD, SNSD channel. Thank you all for participating. If you DM me a handshake address I'll send you some lunch money just because I'm so happy that you participated. And I think this was a success. We'll do it again next week. I'll find another pull request, and hopefully we can get some more active contributors that way. All right, thanks everybody. Bye.